All right, now we'll get back to the questions in just a moment, but now we'd like to welcome Tim back to the show. Welcome
Hey
back,
guys,
Tim.
great to see you again.
Always
Great
a
to
pleasure.
see you again.
All right.
All right, speaking great to see you. I see you brought us.
Goggles, because safety first, last,
Yeah,
and
it's
always.
fun.
And what we're going to work on today is liquid nitrogen.
Great.
All right.
And we'll start right out with pouring it, because I know
All right.
nitrogen is the most common element in the air.
All right.
It's about 4/5 of our atmosphere is nitrogen. And right now, if we can listen to it, let's see if I can
Yeah.
get close enough to it. You can hear it churning and bubbling.
All right.
And
And
we should
that's,
prob-
and that's what we breathe. I was talking with Mr. Z before this. Only 1/5 is oxygen.
Yeah.
Only 1/5, and
know
it's
it was
just as
that
well.
little.
If it was all oxygen, we'd be bright and perky till the first spark, and then things wouldn't be going our way.
You know, we should probably talk about this here. This is kind of cool because what you're seeing
Feel
here.
it. Very cold.
Well, this isn't the nitrogen. You're seeing the moisture in the air that it's actually condensing.
Oh, okay.
You know how you see your breath outside when it's
That's
cold?
what it's doing. I got you.
Yeah.
All right,
So
we're
it's
going to do a
the same.
couple things really quick. Let me pour a little
Sure.
bit into here, because this is another little. These are actually called dewars,
Yeah.
and they're called dewars. A lot of times you ask kids, and they say because they do something, and they do.
And they're doers.
But
Gotcha.
there's a guy named Dewar, Michael Dewar, I believe is his name, and he invented it. What we're going to do is
So these are similar to your old thermoses. There's actually a vacuum there. that you can- so,
Keep things cold.
I was going to show you. Well, I'll put it in there anyways, because this balloon.
Look at that. It's straightening right out.
Well, it's very cold. Liquid nitrogen is, if you go by the scientific scale, Kelvin, it's 73 to 76 Kelvin, which is shirt sleeve weather if you're Kelvin. But if you're Kelvin's cousin Claude in Calgary, Canada, using Celsius, it's minus 196 degrees Celsius. And if you're
cold.
Calvin's friend Frank in Philadelphia, it's minus 320 degrees Fahrenheit. So it's pretty chilly. But what we're going to do is we're going to take a little hot dog.
Hey.
And we're going to take the hot dog, we're going to put it inside. And
All right.
All right.
if you want to take a look, and either one, if you come on over, Ed.
All right. I wanna
Take a look at what's the hot dog, what's doing around the hot dog.
It's bubbling quite a
It's
bit
bubbling
around that
quite a
hot
bit
dog.
around the
It's
hot dog.
reacting with that hot dog.
So we turn
Well, it's not
around.
reacting with it, but
No.
it's
Oh,
causing
how does it?
some of that nitrogen to boil.
Okay.
That's
Yeah.
right, the boil right around it. How do you like your hot dogs?
Well, I like them hot.
Well,
It doesn't sound like
you can't,
that's going to happen.
you can't have
here.
everything, can you?
No.
Let's see if we, oh, it's almost ready. I want it to be well cooked. I don't want you to get ptomaine.
All right, all
Open up that little package right there, the
Gotcha.
little plastic bag.
All right.
And we'll put this, that should be enough probably. Put that right inside.
Okay.
Now
Ooh, that
take
felt-
this
That felt not
and
warm.
put it right inside there.
All right.
Now go ahead and whap it on the table.
That's
No,
hard.
you can
That's
take the
like a
whole
ri-
thing and take the, no, take your,
Whack it.
Oh, like this. Oh, it's like a. Yeah, look at that bad boy. It's
I think
brittle.
twice is good enough.
Yeah, that is. I get the
And,
idea there,
and
Tim.
you turn around, what it does, it's actually broken the hot
Frozen
dog.
hot dog.
Because the
Yeah.
hot dog's frozen. While we're doing that, I'm going to do two things. Now I
right.
can use this. I'm going to put, there's a little ball that has a little hole in it. We'll set it right inside there. So we know that the liquid nitrogen
Not reacting.
is really, really cold.
Yeah.
But what do we use this for?
Warm up water
Warm up water to make tea.
And it
How do
will
we know when
whistle.
the water's boiling?
and when it whistles.
When it whistles. Put a little bit inside there.
All right.
Okay. Oh, it's whistling already.
Yeah. Now, what is boiling?
Well, the nitrogen, I
Well,
guess.
yeah. And so the same with the
Exactly.
water. Boiling is changing from a liquid to a gas.
Oh, and it's causing that thing to act just as if it was boiling hot water.
Exactly.
what-
And guess what
Ah.
kind of tea you can make with
Sometimes
this?
I get it right.
Guess what kind of tea you can make with this?
Not hot, cold tea. Iced
Iced tea. That's right. 2/3 of a pun.
You almost
PU.
had me, Tim. Almost had
All
hot tea
right.
anyway.
So now that's the thing here. I've got something over here. We'll take a look at our balloons.
Yeah.
We've got a balloon. It's got air inside of it. Is it hot, cold, or just right?
It's just right, I'm
Just
sure.
right. It's the Goldilocks effect. Now, what's happening right now is you've got all these air molecules inside. They're very energetic, have a lot of energy. They're pushing to the inside of the balloon and keeping it here.
all right.
Now we'll take.
Man, you got a lot of things in there now, Tim.
And don't forget, righty-tighty, lefty-loosey.
Right.
Now, I know you're saying, Tim, you're putting your hands into that into that liquid nitrogen, and it's really cold. Well, your hand is 400 degrees warmer than the liquid nitrogen.
Okay.
And I'm trusting that all the kids out in TV land aren't going to go rip open their vat of liquid nitrogen and put their hand into it, because chances are they don't have it. But what it does is it's taking all that energy that was with the air, and it's slowing down that energy, and it's causing it to contract just a little bit, and when it does, the balloon shrinks.
Yeah.
But if we blow on the outside,
Oh, look at that. And why can't it reinflate like that?
Nothing left. Those air molecules just turned liquid.
They're
just like
still there.
they're still there. They just became liquid, and
here's another cool thing. We'll do this real quickly.
you can hear them.
You can actually, not only that, because I blew it up myself,
Now, by blowing on it, you're just kind of warming things up again.
just
Right.
warm
Nice
it.
and simple as that.
But if you
Okay.
listen to the inside, there's also something solid in there, and that's the carbon dioxide in my breath. When that freezes, it turns into dry ice. And so
And
that's
that's getting inside the balloon?
That's inside the balloon because I blew it up, and it's carbon dioxide.
Okay, you blew it up.
And the balloon will actually come back to its original
Okay.
condition, which is really pretty cool.
That is very
Actually,
cool.
we can try to do, well, let's do this. We'll do the ping pong ball now.
Okay. All
right.
Now, this
Yeah.
ping pong ball, we put the ping pong ball inside of the liquid nitrogen. I had this tiny little hole in the ping pong ball. And it's just like your rubber ducky. We all have got one. And you take it and you hold it underneath the water
But it
and
still
you
pops back
squeeze
up?
it under the water. What comes out?
Water?
Well, when you first put it in,
Oh, the air.
Air.
Air comes out of it. I see
Air
what you're
comes
saying,
out. And then if you leave it under the water and you just start to release it a little bit, it starts to draw in the water.
Water itself.
Well, right now, if you take a look at that, wish you guys could see it, you can see the air bubbles coming out of the,
Yep, I can see the air bubbles
ping
coming
pong
up the
ball.
front, yes.
So right now, that air is being replaced by the liquid nitrogen.
Okay.
And when it does, we'll pull it out. You might want to step back because sometimes it works a little more violently than I want.
Look at that reaction. Look what's happening.
I heat it up a little bit.
Vegas. Wow, that is impressive.
That's cool. It is. Yeah.
Tim, that's doing much better than we ever did before the
That's
show.
right,
That is
exactly.
fantastic.
And the cool part about it is, we'll do it real quickly because we've got a second. Usually the second time it works better. I have no idea why, and it takes less time. But how it
Wait
works
a minute. Wait, you're
is
Mr.
that,
Science. I need reasons here.
I'm clueless.
already
But the liquid nitrogen turns around inside of that ball and it starts to boil. When it boils, it changes from a liquid to a gas. The gas, it takes up more space. When it takes up more space, it adds pressure inside of the ball. When it does, it gets released through the hole and it
that
starts
causes
spinning.
it to spin.
And
I
it's-
gotcha. So
let's
we're going to
see.
get more.
This might
Step
work a
back,
second time. It should, but it might not.
No, it's
There it
going.
goes.
Feet don't fail me now.
That is
Well,
even better. Well, it's died
oh well.
quicker, but it was doing very well.
So
there for
right
a while.
now, that worked pretty well. That,
Very well.
I feel bad because this balloon probably isn't going to work well because when I put it in there, it wasn't filled up all the way.
You know,
And-
Tim, I want to point out your teapot too, though.
Yeah, look how it's
Those-
crystallized almost like
You know,
that.
like the
yeah.
frost on your windshield when it gets cold.
Condensation.
That's the-
Exactly.
Yeah,
Now,
so it's deposited on there.
That is cool.
the last balloon we've got, I wanted it filled up all the way, but as you saw, I put it in, it's kind of wimpy.
Yeah,
It
I
wasn't
saw
really
that.
filled up. And I'm kind of, well, maybe it'll work, maybe it won't. I don't know. We'll find out.
All right.
You guys may want to back up a
Live
bit.
TV,
Let's
huh?
see if.
Okay. Glad I have the goggles on. Now you don't have to blow on that one. Just kind of. Oh, look, there you go.
I guess
hope-
it did work.
I hope you didn't need that anymore.
No, my budget covers this pretty well.
How was
And,
your budget?
That was really pretty cool because what
very
happened
cool.
is
Well done.
the difference between the regular balloon, that's more of a latex. This is more of a plastic like you would find in a shopping bag that you get from a store, and it's a little bit like if you take a dry sponge and you put it into water, what happens to it? It soaks it up through the pores. Well, this has a lot of pores in it, and the pores are larger than the liquid nitrogen. So it actually soaks the liquid nitrogen inside. When it comes out, it turns on and boils, and it blows up.
Yeah.
Right. Okay. You did great, Tim.
Ah, well,
Thanks.
thanks,
Hey,
Tim.
thanks,
I'm
guys.
glad you,
I had a great
very
time
exciting.
with
You and
I
your Dewar
appreciate it.
Flask were able to join us.
you. Yes, I'm
All right.
happy to be so.
All right, we
right,
want to
great.
thank Tim for being here tonight. Now, to see this experiment again or to learn more about the Rochester Museum and Science Center, head to our website, homeworkhotline.org. Now, stay right there, and we'll be back in just a second.